Let us take this example 2.3. In this, if A vector and B vector are two such vectors, modulus of A vector equal to 4, modulus of B vector is 3, then A vector dot B vector equal to 6. Find the angle between A vector and B vector. So from this problem we got A vector, B vector and A dot B vector's value. Let us draw the picture. Okay, we have the A vector going this way and the B vector drawn this way. Let theta be the angle in between them. Okay, so we have to find the angle between them is the question. Okay, A vector and B vector. We know the formula. A vector dot B vector is this: A vector modulus of B vector into cos theta. We need to find the angle alone. We leave the cos theta here and bring these two guys down here. Okay, that's what gives this one: A vector dot B vector, A vector. Okay, so now substituting the values, A vector dot B vector is going to be 6. We get 6. Modulus of A vector is 4. Modulus of B vector is 3. So 6 by 12, that is equal to 1 by 2. Okay, this implies cos theta equal to 1 by 2. Hence, from the values, theta is equal to pi by 3, that is 60 degrees. Let us take example 2.4. We need to find the angle between the vectors, vector 1 and vector 2 here. Okay, so these are three-dimensional. You can see the Cartesian coordinate thing. Okay, we are going to find the angle between two of these vectors with coordinates given here. Let's take a look at a three-dimensional picture. Let's take a three-dimensional picture where we have x-axis, y-axis and z-axis. Look at that. We can really swing around. So let's put a box around so you get a three-dimensional view of how the thing looks. Can you get a feel? You can see the thing. Z-axis is like this and it is inside here. Okay, y-axis is like this. We got this. One is point A, something like this, and another one is point B, represented by two equal coordinate things. Okay, we are going to find the angle between two. That is what is represented as 2 points here. The first point, if you say like draw a vector there, you get this thing like this. There is another point B, right? The second point. And if we draw a OB vector, so it is going to look like this. Can you see that? It is in the space. It's a three-dimensional vector. You can see the x, y and z axis, and you can see the vectors lying on the space. All we need to find out is the angle between these two vectors. That is, this is the one we want to find. It's going to be theta. Okay, that's for going to be pointing this way. And the points are denoted from x, y and z axis. So this point is point from x, y component and the z component. So likewise, both the points have their own this thing. You can see it here. Okay, this is the representation of this points in the space. Okay, this is the point we saw, the A vector and the B vector in the three-dimensional space. We saw that angle is going to be theta between them. So what is A dot B? We know that when it is A dot B, all we have to do is multiply this with this with this, and this with this. Okay, so when we multiply like that, is 3 into 4, 12, and I dot I is going to be 1, j dot j is 1, k dot k multiplying k is 1. So all we do is just multiply the numbers. So minus 2 plus minus 1 is plus 2, minus 6 into plus 8 is minus 48. So adding up, minus 34 is the answer. So a dot b is going to be minus 34. Modulus of a vector equal to 7. We know how we arrived that one. That is, we have to find a vector dot a vector, that is equal to modulus of a vector the whole square. So square of the same vector, what it is like. So 3 3s are 9, 2 minus 2 4, plus 36, 13 plus 36 is equal to 49, right? So then square root of this is what? Equal to square root of 49, that is going to be 7. Same way we do the b vector. We find b vector is what, do a dot product on into itself, that is equal to b square, that is equal to 16 plus 1 plus 64, 81, equal to 81. So modulus of b vector is going to be 9. So cos theta, so we found the cos theta is from a dot b, a vector dot b vector multiplied by a vector modulus of b vector. So substituting the values, we get this minus 34 by 63. That's all. This is the value of the angle that is between these two vectors.